Hey, what is up guys? This is Dean and I am here to teach you how to understand tensile strength testing. Tensile strength testing is basically testing for the material breaking point. For the example test I'm going to show you today, we are doing a uniaxial test, which means you are testing with an up and down force, not vectoring off to a diagonal angle or anything. What we used in this test was a 3-inch aluminum all thread, which looks like this. This piece is a little bit longer than 3 inches, but what we did is we took this and lathed it down with a mini lathe. We lathed the center inch down to a diameter of 0.125, and then we put it in a scale, a tensile testing scale that is, and pulled it apart, and it broke into two pieces like this. And then we took the data and we find the stress and strain that acted upon that aluminum all thread. So when I tested my piece, draw a little diagram. Okay, basically it ended up looking something like that. Center section 1 inch, this section is 1 inch, and this section is 1 inch. The diameter of this is 0.125. Diameter of these doesn't really matter, although these were, I believe, a 1/4 inch all thread. So we'll start when we're going to find the stress and strain, but we're going to start with our known variables. The length of the material that was acted on was 1 inch. The diameter or width of this material was 0.125 inches. Make note of that there. The force that it took to break the thing, which I learned from the scale that tore it apart, was 727 pounds. The total deformation, or the amount it stretched before it broke, was 0.073 inches. This is the variable for this is represented by the symbol delta. Let's see. Next are before we can do all these are our knowns, but before we can actually carry out all our calculations to find the stress and strain, we have to find the circular area of this right here. So the equation for that, I'll write that variable there. The equation for that is pi times the diameter squared divided by 4. So, A equals, we'll substitute 3.14 for pi times 0.125 squared divided by 4. And what that comes out to is 0.01226563, although you could round it at pretty much any point, you'd still get a fairly close answer. Okay, so we'll write that there for the variable. And so these are known variables. Now we'll write down our unknown variables. Move that up. first one is stress, and that is represented by the symbol sigma. I kind of drew the tail a little long there, by the symbol sigma. And its equation is F divided by the circular area. The second variable, I should say, is the strain, and that is represented by the symbol upsilon. And its equation is delta divided by the length. So we'll start by finding the stress. The stress is, I'll write the equation down again so we remember, and then we substitute in the force, which is 727 pounds, and we divide that by the circular area, which is 0.0122653. Maybe a little bit out of the shot, but you know the number. So you carry that operation out and you get 32,088.21, and that is rounded to the nearest hundredth, pounds per square inch. And there we found the stress. Fairly simple. Pounds square inch. Okay. And now we will find the strain. Oops. My sticky notes are in the way. The strain. And that equation again is, let's do this, strain. And that equation again is upsilon equals delta divided by the length. So we substitute our variables in. And when you divide 0.073, which is the value of delta, surprisingly enough, by 1, surprisingly enough, you get 0.073. And that is the strain. And that pretty much concludes the tensile strength testing. If you have any questions, post it in the comments. I'll probably go through my website and see it, and I can do my best to help you. Catch you guys later.